Hello, Science 30s. I want to go through these notes on alcohols, carboxylic acids, and esters, if I'm saying that right. So you received these already. I just want to work through the practice questions with you and hopefully explain all three of these. So on top of just naming hydrocarbons, we need to know these three other groups in organic chemistry and only to a certain level. So I hope that after this it makes a little more sense. So we're going to start with alcohols. Uh, anytime you see the OH group, then you know you're dealing with an alcohol. So the rules for naming alcohols are listed right here. So you basically just find the OH group and you circle it. And then you determine the parent chain of carbon atoms starting at the end nearest the hydroxyl group. And then all you do is use the method of naming the hydrocarbons to get the initial part of that name. And then you just add um, you're basically just looking for this OL uh, suffix or ending to change it to alcohol. I mean, that you probably heard that term a lot. Then yes, we might have to use a number to determine where the alcohol is placed. So let's just walk through these really fast. So the isopropyl alcohol is actually propane with hydroxyl group stuck on the top. So we would call that, as you can see here, there's the OH group, and then we just go 1, 2, 3 to make sure that that's propane. So we would say propane, but you would put the 2 because anywhere you count from, this would be number 1, 2, or 3. If you count from right to left, or if you go the other way around, it doesn't matter. Okay, so simply stated, that's propan-2-ol. The chemical structure, so jumping over to this example, if we put it on the end now, okay, so instead of being at position 2, now it's at position number 1. Now you really don't need to say propan-1-ol because I don't know, I guess that's just the convention. You don't need to say that. But so this one's just simply called propanol. And one more quick before we work through an example here. Gas line antifreeze, that's a classic one. It's technically methyl alcohol, but the structure for it is just an OH group replacing one of the hydrogens right there. And so to name that, there's only one parent chain. So the initial part of the name would be like you were going to say methane, and then we just change it to methanol. So there's the OL ending and there's the first part there. So we just combine that and we just say it's methanol. All right. So let's quickly look at question number 18. It says draw the chemical structure for 2 alcohol molecules with 3 carbon atoms and 1 hydroxyl group. We've kind of already done that, but I'll just sketch it up here. What it means is you need 3 carbons because that's what it's saying. So they'd all be connected like this. And if there's 7 hydrogens, each carbon needs 4 bonds connected to it. So I could start throwing all the hydrogens in here. I'll just do one. Oops, there'd be a hydrogen up top and a hydrogen down below. Sorry, another hydrogen up top. And setting it up that way, here, I guess I can write it up here. See, right away we have our 7 hydrogens and they're all accounted for. But then if it has 1 hydroxyl group, we could stick it right there. There's the OH. Okay. So if we were to do 2 alcohol molecules, we could put the OH right there, or we could switch it and we could put it on the second carbon. So we could put it right here and then replace that. So we kind of switch those two. So ultimately you could have just propanol, which was the first one that I wrote, or this one that I just did right here would be propan 2-all because it's on the second carbon. Okay, so sorry that's a little awkward, but I think that makes sense. It's just, well, where is it in terms of the different positions you could put the hydroxyl group. Here's an interesting one. Just 19 is cholesterol. Now we say that word all the time, but you probably haven't realized that that means it's an alcohol because it has the ending OL, cholesterol. But this is it. It's a really complex molecule. You can see the whole thing, but it says where is the structure that's similar to alcohols? It's right there. There it is. There's an OH group just sticking off the end of that complex molecule. So the point is, and we've already emphasized that the part of the name that emphasizes that it is an alcohol is the OL ending. Yeah, right there. That way we know it's an alcohol. Okay, for number 20, it has, actually, I guess there is space down here where you could do that. I'll maybe throw that one in here. So ethylene, it says ethane 1,2-diol. It's known as ethylene glycol. I think that's actually paint thinner, but I'd have to check that. Anyway, so if you're going to draw the structure for that, because it's ethane, ethane is 2 carbons. Okay, so we could start with that. But if it says 1 and 2, then that's probably your guess here. Whoops. Here, let me just emphasize that this could be carbon number 1 and this could be carbon number 2. And if it says 1, 2, that means there has to be an OH group off of each one. Okay, so there'd be a hydroxyl group there and a hydroxyl group there. And then, of course, because the carbons need 4 bonds to them, so we could just fill the rest in with hydrogens. Okay, and then the carbons are happy because they have to have 4 bonds connecting to them all the time off of either one. So this would be ethane 1,2-diol. Okay, di meaning 2, so there's 2 alcohols. Okay, all right. So let's carry on here. So that's alcohols. You really just need to be able to know and identify an alcohol as an OH group sticking off of a hydrocarbon somewhere. Where it gets interesting is we can take an alcohol and we can turn it into what's called a carboxylic acid. And the most common one is vinegar, as you can see in the picture. But the carboxylic acid has, they say 2 groups, but you can kind of just lump it all as one. And that really is if there's a carbon double bonded to an oxygen and then single bonded to a hydroxyl group. So you're looking for this structure, COOH, I guess, to identify that it's a carboxylic acid. So I guess that's coming up here to name it. Yeah, I have it in the sorry here. So we'll just go over this one. But in order to actually, what happens here is when you exercise, your body produces lactic acid. That's actually what makes your muscles ache. And your body has a way of addressing that acid by neutralizing it a little bit. And the reason that'll happen is, let's just look quickly at 21. This is lactic acid. And in the presence of water, so I'm just going to write it right here, and you can do this too. In the presence of water, what happens is this hydrogen right here, because it's an acid, right? If you remember, acids are proton donors. They're happy to give up their hydrogen atom. And in this case, it does. So this hydrogen atom joins water, and it actually makes H3O plus. So it makes the hydronium ion. And then you're left with this molecule, and I'll do my best to sketch it, because really all I did was I ripped off that hydrogen. So now I have this carbon, and that's connected to, I didn't change anything else on here, right? So we got OH here, another hydrogen, and then another carbon, and 3 more hydrogens. So none of that changed, if that makes sense. And but all of this molecule is now negatively charged, okay? Because it gave up the proton, so now it's negatively charged. And this, the buildup of that in your, well, basically we're building up this acid, this H3O plus is building up in your muscles. So to neutralize that, you can bring in, and our body has this, you can bring in these guys, okay? So hydrogen phosphate ions and dihydrogen phosphate ions, both of those guys. They can come in and they will take the hydrogen off of H3O plus. They'll come grab one and thereby neutralize the acid. So this is basically what buffering is. You guys remember that from before, and the body's able to do that. There's certain limits, but the body can do it to basically keep your muscles from aching. And in part, your muscles ache too much, it hurts, and so you stop exercising, and then there's time for your body to recover. Anyway, it's very clever how it all works. So I guess for this exercise, we could identify the hydroxyl, carbonyl, and carboxylic, or the carboxyl functional groups when it asks you to do that. Obviously, the hydroxyl group is there. The carbonyl group is just this, okay, and then the carboxyl functional group is the whole thing. So anyway, if you're trying to track all of that, that's really what it refers to back up here. So the carboxyl functional group, you're just looking for the COOH is what they're calling this carboxyl functional group. So I'm not too much worried about B and C because we've already talked about that in terms of how the presence of these other hydrogen phosphate ions and dihydrogen phosphate ions, they actually help to buffer the acid. So naming carboxylic acids, this one's pretty easy. You basically name the hydrocarbon molecule and then you change the ending. So typically for the molecules we're going to use, you're not going to deal with anything more than 3 carbons. So propanoic acid, or sorry, you change the ending to OIC, oik. This one right there, and then add the word acid. Okay, so this is how you name the carboxylic acid. It would have that, the base word plus OIC as the ending, and then the word acid. So propanoic acid, the propane part, as you can see, propane indicates that there's 3 atoms or 3 carbons, and then the OIC tells you it's a carboxylic acid. Oh, sorry, then you add the word acid after that. Okay, so the structure would look like this. You see this here. There'd be 3 carbons, and then you have the whole carboxyl functional group, which is all of that guy. Okay, so really that's what you're looking for. So let's carry on to, I think we're ready to talk about esters now. Yes. So esters are the last one. These guys are pretty interesting because all they are is a combination of alcohols and carboxylic acids. And this is really cool because you can make a whole bunch of different compounds that have an odor. When I was in university, we made banana oil out of a couple of esters just by reacting them. And it was really cool because as soon as you make it, you can smell it. And so the food industry they do all kinds of research to make esters that will produce certain aromas. So if you look here, this shows an alcohol in blue reacting with a carboxylic acid in red. And what's really clever here is that water will form from this hydrogen here and this OH group, they just come together and they make water. And when they do that, the water leaves, as you can see here, it's gone, and then you're left with an ester. Now, the group that you're looking for with an ester is a carbon double bonded to an oxygen and single bonded to another oxygen. That's what you're looking for. If you see that group anywhere in a molecule, you know you have an ester. And as in the notes, if you caught that, it happens in the middle of a compound. It's not at the end. It's not like the carboxylic acid where it's on the end, or the alcohol, which is usually on the end or sticking off. The ester is in between, or it's in the middle of the final product, which would be all of this. It's in somewhere embedded inside. If that helps, that's trying to simplify it a bit. So when it comes to naming an ester, you have to first find the ester, okay? And we kind of already did this, so I'll maybe just refer back to it. So we did find the ester, it's right there, okay, the ester group, and then it says circle the chains of carbons, maybe we'll switch to blue here, that are coming off of the ester. So there's just a carbon here, and then there's two carbons here. So we count the carbons that, or include the carbon that's double bonded to the oxygen, okay? So those are the two chains that we have to name. And actually these, let's just keep going here. So once you've identified those carbons, then we name the alcohol part first. So if you see the alcohol is this first carbon. Okay, this one here is the alcohol, and this was the acid, the carboxylic acid. So we name the alcohol first. It's just how it's done. And in this case, it's one carbon, so that would be methyl, just like it says in this example. The prefix methyl is used because there's only one. And then to name the second part, you count the number of carbons in the acid part. So in this case up here, there's two. You can see that. So then in step 5, it says if it contains one carbon, we use methane. Well, we're using the example above, so that's actually going to be ethane, because it would be like ethane. So if I copied this example, but if we're actually naming what I've been focusing on here, we're naming this ester right here. It has two carbons at the end. So then we would combine both of those. So here in step 3, it is methyl, but the carboxylic acid isn't methane, it's ethane, or it's ethane. So then we would add the O8 ending. So it's methyl ethanoate. Methyl ethanoate would be the ester that I was playing around with right here. Okay, if that makes sense. So I just wanted to write that out so you could see that those would be the steps that you would take. Now let's just do a couple more just to kind of give you some exposure. Here, this is just a cool drawing of a really complex one. They can get, the complexity is kind of through the roof here. There's almost infinite number of combinations. But if you see this is a fat molecule with a huge fatty acid portion onto it. But you can see the groups right there. So there's the ester, okay? This group here, C double bonded to O like that. And this one here hasn't formed yet. So down here, see, we can get water. This water here will leave. It's showing it kind of in the intermediate step. So that water will leave, and then you'll get the ester will form right there and connect to the carbon, and then we get this really complex molecule. Okay, so that's the forming of the ester in terms of how it would connect. So on this page, let's just end on this one here. So this is just another example, and how would we name it? So what's happening is we have propanol, which is an alcohol, and it reacts with ethanoic acid. And bang, you see this, the H and the OH, that will leave, that'll form water and just go away. And then those two structures will totally connect to each other, which they do down here in the products. But what do we just make? So again, let's just review this. What we have to do, you find this is the ester right here, okay? And we identify the carbon chains off of both. So, sorry, I guess I didn't say, I ran over that fast in the instructions. Let me just back up to this, because the first part is you label or you locate the chain of carbon atoms that's attached to the functional group by a single bond to the oxygen atom. We start with that first because that's where the alcohol is. Sorry, I jumped over that a little bit. So what that means is the chain that we're gonna name first is this chain. This chain is bonded with a single bond to an oxygen, which is then bonded to the carbon. So we name the chain. It's really the alcohol that we're naming first. Okay, so this would be propyl. Okay, it's not propane because it's a branch, so we say propyl, and then the other chain includes the carbon that's part of the ester, and so this would be propyl, and there's two carbons, so that's F, ETH. And it would be ethane if it was its own hydrocarbon, but we say ethane, and then we add the word the suffix O8. So the name of this ester is propyl ethanoate. Okay. Most of the combinations are going to be, again, 2 or 3. So if you get comfortable with those, I know they can get really complex, but if you're comfortable with at least 2 or 3, you guys you'll be laughing. Okay. So let's just end on a couple more examples, because we can do 24 here. So the example of the ester on the left is produces an aroma similar to raspberries. That's kind of cool. So again, the same thing. They're showing you that you find the ester right there. Sorry, it includes that. So we name this part, we name first, and then this is the part that's named second. And you can see that they name the first part ethane or ethyl because it's ethane. So you go with the prefix ethyl. Here it is right here, ethyl. And then because the second one or the second molecule is one carbon, that would be methane. And then you change it to O8. So really you're looking for either OL, which is alcohol, oic acid, which would be a carboxylic acid, or you're looking for O8, which is the ester. So I think you guys can follow that as you kind of work through it. So let's just end on 24. It says draw the structural drawings for the reaction where possible, write the names. So here, all we need to see here is this is the alcohol for number 1. It's got the OH group right there, and the carboxylic acid has its, this is the group here that's going to react. Basically, this hydrogen right here is going to combine with those, and then what's remaining will stick there. So in effect, this is for A. What we're going to end up with, if I can sketch it here, we're going to still have this that's called salicylic. I think I said that right, acid. So it's going to have this carbon double bonded to the oxygen, and then we'll still have it'll be single bonded to this oxygen, and then the hydrocarbon will now be stuck to it. Okay, so this part right here just kind of came down and boom, is stuck inside. Okay, so that's what we make. Now, that's actually called methyl salicylate. You don't need to worry about naming that one, but it's actually kind of a root beer odor, apparently, which is kind of cool, what that is. So all I want you to see is that's what would form, okay, in that case. Now, if we look at B, B shows it's 2 carbons, so that would be ethanol, the alcohol, and then it's 1 carbon for the carboxylic acid, so that would be methanoic acid for this one. So this one's methanoic acid, and this one is ethanol. So if we add those two together, let me just sketch it like this. So the first one has 2 carbons. We've got 3 hydrogens off of him. And then he has 2 hydrogens, but then he also has the alcohol group. So there's ethanol. And then we add to that the carbon, double bonded here, OH there, and then another H there. So, sorry, I wrote that a little bit rough. So this here forms the water. And then what we're left with, here, let's just come down here. What we're left with now is, and I won't write all the hydrogens. You can see like some of the conventional methods can speed that up. But anyway, so it would look like this. And yeah. So then we got to name this guy. So the carboxyl group, or sorry, the ester is here. Here's the ester. Okay. So this is the first part that we're going to name, and that would be ethyl. And then the second part would be, sorry, there shouldn't be a hyphen there. Let's just back up. Yeah, it's just ethyl and then methan. Oh, wait. For naming that ester. Okay. So I'll just do the last one down here. I guess we got some space, but you guys can refer to that in your notes. So the last one is, oh wait, I better check it. It's ethanol and ethanoic acid. Okay, so I guess this is C. Ethanol is 2 carbons. We already did that one. So there it would be without all the hydrogens. And then ethanoic acid is 2 carbons as well, but it's going to have the carbonyl and hydroxyl group like this, the COOH on the end. And then this, of course, has the regular hydrogens. So the catch here is basically it's these hydrogens and the 1 oxygen, they form water. And then we're left with the ester. So in this case, we're using both ethane, like 2 carbons together. So it'll be ethyl ethane O8 for that ester. Okay. So I guess just to end with this then, what's really cool is if you make alcohols and acids that have 2 groups, like 2 hydroxyl groups for the alcohol and 2 carbonyl groups or on the carboxylic acid, it's like having like 2 Lego pieces, and you can connect more Lego pieces on each end. And it's crazy because this is exactly how they make polymers, which, as you see that word here, polymer is it's the name given to any large molecule that's formed by the joining of a whole bunch of small molecules. So if you want to make a really long piece of Lego, you just get all the individual pieces and click them together. And yeah, they overlap. You could overlap them. But that's exactly how you make a polyester. I just think that's crazy because we use the word polyester all the time and we don't even think about what it means in terms of what our clothes are made of primarily. It's like, oh, is it polyester, whatever, blah. But poly means more than one, and ester, we've just been learning about those. And in this very clever setup, we can make millions of connections here and thereby produce what we call polyester, which heavens, we make all kinds of things with polyester rope and life jackets and clothes and oh my goodness, everything. So it's a super useful material, but all you need to know is that you can take, if we just look at the alcohol first, you can see this alcohol here has an OH group here and an OH group there, and this carboxylic acid, it has a the its reacting group there and there. So these guys can team up, and then another alcohol can come in and attach to this side, and then another carboxylic acid come over here. So you can see we can just start going ching, ching, ching. We can make them like crazy. And this is the polyester right here because, I mean, this just shows the first bond. So it made an ester right there. But look, it's ready to make another ester over here, and it's ready to make another ester over there. And it'll just go ding, ding, ding. And you can get huge, huge chains. So they call it the Dacron reaction, at least in this illustration, with these two types. So I guess that's propanol, the alcohol, and this carboxylic acid, which is branched off of a benzene ring. So definitely not the only combinations, but there's lots of them. So I guess the last thing you should note is that these polyesters are really stable and they don't break down in landfills or whatever. And so environmentally, they can be a problem because, and as you know, most plastics, we try to recycle those plastics because they just like, if you chuck them in the landfill, they just don't break down for a super long time. So anyway, I hope that's helpful, and we'll be getting out the last section of notes shortly, and we're going to start reviewing from there. So thanks.